For continuing the 2.4 notes, the delta epsilon definition of a limit. So example 2, the limit as x goes to 10 of 3 minus 2/5 x equals negative 1. Part A, what's the delta in terms of epsilon needed to prove the limit? Alright, so the difference with example 1 is that the epsilon is a variable. It's no longer a particular value like 1. And this is the usual case. So what we're going to try to do is trying to find a function of delta in terms of epsilon, so that instead of having this particular epsilon value of 1 up here and finding the specific delta, it actually turns out for linear functions we can come up with a very easy equation, delta equals something in terms of epsilon. And so then if we are given epsilon equals 0.5, we could easily plug that in. Now for nonlinear functions it's not so easy, and we're not going to do this type of problem for nonlinear functions. That is not just something that typically you can just do some algebra. You need to do that minimum thing, kind of like what we're doing up here, which I think is a fair expectation for when we have a particular epsilon value. But when it's in general, it's harder. So just a heads up there. If you're looking at the book, in other words, then we're not going to do absolutely everything that's in the book here. Alrighty, so let's get started on this. How do we even approach this problem? So what you do is you start with your definition and the part that says the absolute value of f of x minus L is less than epsilon. And so our goal here, because we're trying to find delta in terms of epsilon, is we're going to do some algebra on that to get the other part of the definition that's in terms of delta. So get that absolute value of x minus a with this inequality we're starting with. We'll just say on the left, because that's where the inequality stuff is in this one. Then the right-hand side is what you let your delta equal. So that's pretty much it. Now we'll go over how you do this algebra. So let's actually do what we're saying we're going to do. F of x minus L, absolute value of that is less than epsilon. So for our particular function, our f of x is 3 minus 2/5 x, and minus our L, which is negative 1, also from up here. And then that's less than epsilon. Epsilon is not 1 in this case, it's just epsilon. Now take a look at that, and what we're going to try to get on the left is the absolute value of x minus a, which in our case is the absolute value of x minus our a being 10. Now the first thing that you typically do is just combine like terms. So, you know, this isn't simplified. So let's keep going there. We can take 3 minus negative 1 and get 4. Notice that the x part has to come first, so I'm going to write this as negative 2/5 x plus 4. Okay, so 3 minus negative 1 is 4. I don't know what I said last time. Hopefully I said the right thing, but it's 4. Okay, here we go. Now, that's still not absolute value of x minus 10. So notice one thing is that we have a coefficient of 1 on there, and that's always going to be the case. So if you don't have a coefficient of 1 here, you got to get rid of that thing. So the algebra here, we have to deal with that absolute value business, but it's actually not too bad here. What we're going to try to do here is get rid of that negative 2/5 by factoring it out and dividing by it to get it on the other side. In other words, get a coefficient of 1 here. So there's different ways to do this, but I think the way that works the best for most people is to do a little prep work here. Taking out the negative 2/5 from the negative 2/5 x is a piece of cake. But for the 4, how can you write that with a negative 2/5 as a factor? Well, I could write this as minus the negative first of all. And then the 2 is easily obtained by writing 4 is 2 times 2. Putting this over 5 gets me the 5, but to do that in a legit way, I have to also multiply the top by 5. So now this thing is prepped to pull out a negative 2/5. Now I'm just pulling it out, not out of the absolute values yet, because we should talk about that separately. But if I factor out the negative 2/5, I get x minus, let's see here, take out a negative 2/5, x minus, I get 10. Now you'll start to notice that's a good thing, because now you should be able to see like, oh yeah, x minus 10 in the absolute value, that's definitely something that should happen. And if you're doing this right, this will work out naturally. Now next thing, because you have that absolute value there, when you factor something out, you need to take the absolute value of it. So that justifies this next step. Now, go ahead and solve by multiplying both sides by 5/2, for example, and we're going to have 5/2 epsilon on the right. And here we have our absolute value of x minus a. So the last step here is just to let delta equal whatever's on the right-hand side. And by using that other equation in terms of the y stuff, then we're able to figure out exactly what the delta should be in terms of epsilon, so that we always have the absolute value of x minus 10 less than that value that corresponds with that epsilon. So our answer is delta is equal to 5 epsilon over 2. Idea here is someone gave me an epsilon of 0.1. I would just plug it in here, delta would get spit out. Now we don't have this minimum business, just speaking to that, because it's a linear function. And so where we're taking our L, the epsilon is always equidistant from L, but the delta sometimes is not. It is not when you have nonlinear function. Notice that when we map down our epsilons, and I draw this right, that these deltas are the same for linear functions. And those are the only kind that we're going to do where you find delta in general in terms of epsilon. So those deltas equal each other. Alright, so that's it. And there will be one more example in the next recording.